Hello everyone, welcome back to CSP channel, Learn Easy Way of Physics. This is Chary, Physics faculty. Let me go to discuss about the problems today based on the concept lecture number 9. First problem is here, when a string is divided into three segments of length L1, L2 and L3, the fundamental frequencies of these three segments are N1, N2 and N3 respectively. The original fundamental frequency of the string is, we have to calculate the original fundamental frequency here. We know that already we have discussed in the previous class about the fundamental frequency of vibrating string. That is n is equals to 1 by 2L root T by mu. So here is n is equal to 1 by 2L into root T by mu. This is the fundamental frequency of vibrating string formula. So according to that formula, here is the tension and the linear density is constant. Then the relation can be written as n is inversely proportional to its length of the string. Now actually we have to calculate, here is fundamental frequency of the string, original fundamental frequency of the string. Now here is when a string is divided into three segments of lengths L1, L2 and L3. We need to take length of these segments from this formula. So how is it possible to require the length of the strings here for three segments? Here is n is equals to, here is k by L, where k is constant. K is proportional constant. Proportional constant. This is proportional constant, and here is, we need to take L is equals to, here is k by n. Now how many segments are divided for that string? Three segments. Those lengths are given already in the question, L1, L2, L3. Here is, we take the first segment, the length is L1. L1 is equals to k by n1 here, and L2 is equals to k by n2. This is length of the second segment, and L3 similarly, L3 is equals to, here is k by n3. So the total length of the string is, L is equals to, here is sum of individual length of the segments L1 plus L2 plus L3. We know that L1, L2, L3, these three formulas substitute in the place of L1, L2 and L3. Here is what is L, that is k by n, equal to, here k by n1 plus k by n2 plus k by n3. So we should take common k. Here is 1 by n1 plus 1 by n2 plus 1 by n3. Here k get cancelled. Finally, the original fundamental frequency 1 by n is equal to 1 by n1 plus 1 by n2 plus 1 by n3. This is the original fundamental frequency of the string. It is 1 by n is equal to 1 by n1 plus 1 by n2 plus 1 by n3. Second problem is a wire having a linear mass density 5.0 into 10 power minus 3 kilograms per meter is stretched between two rigid supports with a tension of 450 newtons. 450 newtons. The wire resonates at a frequency of 420 Hz The next higher frequency at which the same wire resonates is 490 Hz. Find the length of the wire. So here is one of the wire. Here is wire is attached to rigid supports. A wire having a linear mass density is given. Linear mass density means that is mu value. That is 5.0 into 10 power minus 3 kilograms per meters. So what is its tension? The tension in the string is given T is equal to 450 newtons. Okay, after attaching two rigid supports, that is vibrating. Number of harmonics are formed between the two rigid supports. We don't know how many harmonics are formed between the supports, right? And we have to calculate it, that is, and get its vibrating with the frequencies of 420 Hz is given already frequency, and we have to calculate the first of all here frequency. What is the frequency is given? At frequency of 420 Hz. At frequency F1 is equal to 420 Hz. Okay. N the harmonics are formed. N the harmonics are formed. Harmonics are formed. So the fundamental frequency considered F1 is equal to, here is N by 2L root T by mu. We have discussed in the previous class that is N is equal to 1 by 2L into root T by mu. Here is F1 equal to N by 2L root T by mu. Here N is integer. Number of harmonics are formed after vibrating the strings between the two rigid supports. So here consider like this. What is F1? F1 is 420 Hz here. 420, that is equal to N by 2L root T by mu. T by mu. This is the first equation. And the next one, the next higher frequency at which the same wire resonates is 490 Hz. The same wire, but the frequency is maximum here, 490 Hz. Okay, when it is vibrating with the frequency 490 Hz, we considered N plus 1 nth harmonics are formed between the two supports. So, here is at frequency F2 is equal to 490 Hz. 490 Hz. We considered N plus 1 nth harmonics are formed. Harmonics are formed. Harmonics are formed. So, and here is F2. The fundamental frequency N plus 1 is divided by 2L root T by mu here. We know that F2 490 here 490 N plus 1 by 2 L into root T by mu. This is second equation. So equation 2 is divided by equation 1. We can do like that. 490 is divided by, here is 420. 420. That is equal to N plus 1. N plus 1 is divided by, here is N. Here 2L and 2L get cancelled. Root T by mu get cancelled. So after cancellation of these two, we have written like this 490 by 420, that is equal to N plus 1 by N. We have to calculate that which is how many harmonics are formed after vibrations, after comparison of both frequencies of the string. Okay, we have to calculate the number of harmonics between two rigid supports. Here 0 0 cancelled. and 7 by 6. Here is 7 by 6 is equal to n plus 1 is divided by n. Do cross multiplication. And here is 7n, that is equal to 6n plus 6. 7n minus 6n, that is equal to 6. Here is n is equal to 6. This value is putting in equation 1. From the equation 1, that is f1 is equal to n by n is divided by 2l into root t by mu. We know the fundamental frequency for the first string, that is the frequency is 420, 420 this is, and 420 is equal to n. What is n value? 6. 6 is divided by 2l. 2l same as it is. T value is tension in the string. Where is that? That is 450. 450 is divided by mu. Mu is 5 into 10 power minus 3. That is 420 is equal to 6 by 2l 5 nines. 9 into 10 power 4 here. That is 6 by 2l into 3 into 10 square here. That is 420. 420. We need to take 2l, and 2l is equal to, here is 6 by 420 into 3 into 10 square. Now 2 ones, 2 threes, and 3 ones, 3 fours, 0. Next one is right, L is equal to, here is 300. 1 0 1 0 cancel here, and 300. 2 sevens. 2 sevens. Okay. 30 is there. 30 is there. Here 2 ones, 2 fives. Here 15 by 7 will come. 15 by 7. So finally that is equal to 2.1 meters. 7 twos and 7 ones. 2.1 meters. Its total length is 2.1 meters. You can see that 2L is equal to 6 by 420. After how do we cancellations for this? Okay, to find out the length of the string, L is equal to 15 by 7. Final its length is 2.1 meters. Next, third problem is, if the tension and the diameter of a sonometer of wire fundamental frequency N is doubled and density is halved, then the fundamental frequency will be, we have to calculate the new fundamental frequency, okay, from this problem. Now, here is the tension is doubled and the diameter of the wire is doubled. The new tension is considered T dash is equals to, here is 2T, and diameter, we know that the diameter of the wire it is equals to, here is 2R, but the new diameter it is doubled. D dash is equals to 2R here, that is 4R. But we need to calculate the radius of wire. R is equals to, that is D by 2. But the new radius R dash is equals to, here is D dash by 2, that is equal to, what is D dash? That is 4R by 2, that is, here is 2R, 2 ones, 2 twos. So, the new radius of the wire R dash is equal to, here is 2R. New density of the wire rho dash is equal to, here is, okay, rho by 2. This is half of its initial density. That is given, density is halved. Now the fundamental frequency N is equal to the fundamental frequency of stretched string on sonometer. So N is equals to, here is a 1 by 2L root T by mu. We know that. Next we have to find out the new frequency of the stretched string. So before we can find out the new frequency of the stretched strings, we can write it here. N is equal to 2L root T by, here is mu is nothing but rho A. Since here is linear density, mu is equals to rho A. Now here that is equals to 1 by 2L, N is equals to 1 by 2L root T by rho A, rho into A, area of the wire, that is pi r square. So then we can calculate the new frequency of the wire. Okay, after changing the tension, radius and the density. So the new frequency of the stretched string N dash is equals to 1 by 2L root T dash is divided by, here is rho dash, pi r dash square, like this. Now that is equals to 1 by 2L root, what is T dash? T dash is here 2T. 2T is divided by rho dash is rho by 2, here is rho by 2, pi r dash square into, what is r dash square? 2r whole square. 2r whole square. Here is that is equals to 1 by 2L root. Here 2t is there. 2t is divided by, here is rho by 2 pi 4r square. 4r square. Now here is 2 ones are 2 2's. Here 2 get cancelled. 2 get cancelled. The remaining part is 1 by 2L root, okay, T by, here is rho pi r square is there. So this is N dash. So N dash is equal to, actually 1 by 2L under root of 2L into root T by rho pi r square is, that is fundamental frequency, 1 by 2L into root T by rho pi r square. Okay, in the place we can write it N. N dash is equals to, here is N. This is the answer. N dash is equal to N. Next question is, the length of the wire between two ends of a sonometer is 100 centimeters. What should be the positions of two bridges below the wire so that the three segments of the wire have their fundamental frequencies in the ratio 1:3:5. So what should be the positions of two bridges below the wire? That we have to calculate now. So the length of the wire between two ends of a sonometer is 100 centimeters. First of all, here is a wire is taken. Below the wire, two bridges. Have two bridges. And we know that this is, here is one of the pulley. Sonometer we discussed in the previous class. And some weight is attached to the string. It is a pulley. Okay. So the weight here is attached to the string because of it's getting tension. The string is getting sudden tension, you know, and so the first segment is L1 from here to here, and the second segment is, its length is L2, and the third segment is L3, okay, between the positions. The total length of the wire is taken here is given 100 centimeters in the question. And where we should keep these two bridges to produce the maximum sound. And the frequency is given, that is 1:3:5. So initially the bridge placed at A. Okay, now here is L1, L2, L3. These are lengths of the segments. Here is what we should calculate. First of all, the positions of two bridges below the wire so that the three segments of the wire have their fundamental frequency. The fundamental frequency ratio is given. N1 is to N2 is to N3 is equal to 1 is to 3 is to 5, like this is given. We need to find out the ratio of lengths. That is L1 is to L2 is to L3. That is equals to 1 is 1 by 3 is 1 by 5. Okay, since here is we know that n is inversely proportional to its length according to the first law of stretch testing we discussed in the previous class, right? And see, here is write it like this also. L1 is, L2 is, L3, that is equals to, after doing the LCM, here is 15 is, here is 5 is, here is 3, 5 is to 3. Now here let x be the common factor. X be the common factor. Let, we have to take x be the common factor. Common factor. X be the common factor we considered, and we can write it here. 15x is to 5x is to, and next one is 3x, means here is 15x plus 5x plus 3x, that is equals to the total length. So 15x plus 5x plus 3x, the total length of these segments is given, that is 100. Means the length of this string is 100 is given. 15 plus 5, 20, 20 plus 3, 23x is equal to 100. Okay, we have to calculate x is equal to, here is 100 by 23. Now the L1 length is, L1 is equals to, here is 15x is considered, and that is equals to 15 into, what is x value? X is 100 by 23, finally that is equals to 1500 by 23. First one is over. And the second one is length of the segment. L2 is equal to, here is, I have written 5x. That means that is equals to 5 into x value. Substitute in the place of x. That is 100 by 23. That is equals to 500 by 23. 500 by 23. Now next one. L3 is equals to, here is the centimeter, here is centimeters. Now L3, what is L3 here? 3x is considered, 3x is equals to 3 into, here is 100 by 23, finally that is equals to 300 by 23 centimeters. So where should we keep two bridges below the string here? Okay, so we should keep two bridges below the string from 1500 by 23 centimeters and 2000 by 23 centimeters. I am writing here. We should keep the positions of two bridges, okay, from, here is from A, that is 1500, here is 1500 by 23 centimeters and 2000 by 23 centimeters. We should keep like this, two bridges, okay, below the string. Okay, from here to there, 1500 by 23 centimeters. After 1500 by 23, Then above the 1500, like here is taken as 2000 by 23 centimeters. Okay, we should keep two bridges below the string. The positions of two bridges are taking here 1500 by 23 centimeters and 2000 by 23 centimeters. The next question is a granite rod of 60 centimeters. Length is clamped at its middle point and is set into longitudinal vibrations. The density of granite is 2.7 into 10 power 3 kilograms per meter cube and its Young's modulus is 9.27 into 10 power 10 pascals. What will be the fundamental frequency of the longitudinal vibrations? Suppose here is granite rod is given. Granite rod. This is one of the rod. The middle clamped. So it is clamped. Okay, rod is 60 centimeters. Its length is 60 centimeters. It is clamped in the middle of the rod, middle point, and is set into longitudinal vibrations. Okay, it can produce longitudinal vibrations at two ends, but it is attached with a clamp where it is in the middle. So longitudinal vibrations, the density of granite is given. Density of granite, rho is equal to, here is 2.7 into 10 to the power of 3 kilograms per meter cube. And its Young's modulus. Young's modulus y equal to, here is 9.27 into 10 power 10 pascals. What will be the fundamental frequency? We have to calculate the fundamental frequency of vibrating of this rod at two ends. Here is, we know the fundamental frequency, that is n is equals to 1 by 2L root T by mu. In the place of T and in the place of mu, we can write it here. N is equal to 1 by 2L and a root. Here is, so Y is divided by rho. Young's modulus is divided by rho because of, we have learnt in the first year, that is Young's modulus Y is equals to FL by A delta L. We know that. We discussed in the previous class, that is in first year. So FL by A delta L. But we need to, here is F is nothing but T. Now I can write it, Y is equals to TL is divided by A delta L. So we need to take T here, means that is Y A delta L is divided by, here is L, that is capital T. T equal to YA delta L by L. Here is mu is nothing but, we know that mu is equals to rho A. We know that. These two conditions, when we have to substitute it here. So, what formula will come? N is equals to, here is 1 by 2L and a root T. T is nothing but YA delta L by L here. Delta L by L. Delta L by L. So, here is mu is rho A. Rho A. L will come down, no? L, like this. A get cancelled. Here is no changing the length. Length could not be changed. Here that is at the place of delta L is taking delta L is placed here, only L. So LL get cancelled. The remaining word is, what is that? Here is root Y by rho. So finally we have to write the fundamental frequency. N is equals to 1 by 2L into root Y by rho is the formula. How it came, you know. So when change does not change the length here. So at the place of delta L, we have written only L. LL get cancelled. The remaining terms are, here is taking only root y by rho. So finally we have written the fundamental frequency n is equals to 1 by 2L into root y by rho. Like this we have taken. So we know the values which are Young's modulus and density of this rod. So substituting here 1 by 2L. 60 centimeters is given. We should convert in meters. Here is L is equals to 60 centimeters. That means that is equals to 60 into 10 power minus 2 meters. Substituting here 2 into 60 into 10 power minus 2 root. What is y value? Y value is 9.27. 9.27 into 10 power 10 is divided by, what is rho value? 2.7. 2.7 into 10 power 3. So now that is equals to, here is 120 means 12 into 10 power minus 1 and into 9.27. Here is 3.4. 3.4 into 10 power 10 power 3 minus 3. It's taking numerator. So 10 power minus 3, 10 power of 10 into 10 power minus 3, 10 power 7. 10 power 7 like this. And here is written, that is 10 by 12 root 3.4, 34 into 10 power 6. Now that is equals to 10 power 12 into root 34. I think 5.8, approximately 5.8 into 10 power 3. 10 power 3 here, right? And here is 58 by 12 into 10 power 3. So 2 6, 2 2s and 2 9s, 29. And next 29 by 6, 29 by 6 into 10 power 3. So that is equals to, here is 4.8. 6 4s, 24, 4.8 approximately into 4.8 will come 10 power 3. So finally that is approximately 5 kilowatt. What we have to calculate here? Frequency, the fundamental frequency, 5 kilohertz. So here kilo is already at 10 power 3 is there. At the place of 10 power 3 we can write it kilo. So 5 kilohertz. What is the fundamental frequency of vibrating this rod? That is 5 kilohertz is the answer. Here the next question is, two wires W1 and W2 have the same radius R and respective densities ρ1 and ρ2 such that ρ2 is equals to 4 times of ρ1. They are joined together at the point O as shown in figure. The combination is used as a sonometer wire and kept under tension capital T. The point O is midway between the two bridges. When a stationary wave is set up in the composite wire, the joint is found to be a node. The ratio of the number of antinodes formed in W1 and W2 is like this. So we have to calculate the ratio of number of antinodes, means number of modes. Okay, now here is the given diagram in the question. This is the one of the wire. Okay, they are passing through the two edges over on the pulley, and the weight is attached to the string due to it's getting a certain tension. So the first wire density is ρ1. Okay, the second wire density is ρ2. Here W1, W2, there are two wires. First one W1, first one wire, and the second one wire is W2. And they are attached, okay, at the center, that is O. Here is given in the diagram. According to this diagram, so we have to calculate, according to this diagram, we have to calculate the ratio of antinodes, okay, number of ratio of antinodes or number of modes, like this. Here is what are the given, have the same radius is same, but the density will be different here. So for the first wire, the frequency is writing F1 equal to, here is n by 2L into root T by mu. We know that. But here is n is not a frequency. Here is number of modes. Here is number of antinodes, like this. F1 is frequency, already here is mentioned. And okay, now since here mu is equals to rho A is taking, F1 equals to n by 2L root T by rho A. Here is F1, here is a rho 1. Okay, here is N1, number of modes, N1. Now, similarly, the frequency for the second wire, F2 is equals to N2 by 2L root T by rho 2A. So here both frequencies are same. Okay, this is the first equation and this is the second equation, equating both frequencies, that is F1 equal to, here is F2. So what is F1? Here is N1 by 2L into root T by rho 1A, that is equals to N2 by 2L root into root T by rho 2A. Right, here 2L get cancelled and A get cancelled, root A, and the root T get cancelled. The remaining N1 by N2 is equals to, here is root, rho 1 will go to that side, rho 1 by rho 2. Okay, N1 by N2 equal to under root of rho 1 by rho 2. These N1, N2 are number of modes or number of antinodes. Here is given a rho 2. What is the condition? Rho 2 equal to 4 times of rho 1 is given. Since rho 2 equal to, here is 4 times of rho 1, N1 by N2 is equal to under root of rho 1 by 4 rho 1 will get cancelled, that is 1 by 2. So finally, what is our answer? N1 by N2 is equals to, here is 1 by 2. So the ratio of the number of antinodes, that is equal to 1 by 2. 1 is to 2. Okay, the next question is, the total length of a sonometer wire between fixed ends is 110 centimeters. Two bridges are placed to divide the length of wire in the ratio 6:3:2. The tension in the wire is 400 newtons and the mass per unit length 0.01 kilograms per meter. So here is what is the minimum common frequency with which 3 parts can vibrate. Here is L1, this is L2, and this is L3. Here is pulley, this is weight. Sonometer, 2 bridges. Okay, 3 parts from here to here, from here to here, and next to here to here, like this. Okay. Like this. The length of the wire in the ratio is given, and the fixed ends is 110 centimeters from here to here, 110 centimeters. So L is equals to here 110 centimeters, should convert in meters, 0 into 10 power minus 2 meters. Finally here 1.1 meters, like this. And tension in the string T is given already, that is 400 newtons. Mass per unit length, that means that is a linear density. Mu is given 0.01 kilograms per meters. What is the fundamental frequency? N is equals to 1 by 2L root T by V. I am substituting here. Okay. Here is N is equals to 1 by 2L. 1 by 2 into what is L value? 1.1. 1.1. Okay. Into root, what is T? Capital T. T value is 400 newtons. 400 is divided by mu. Mu is 0.01. 0.01. Here is by 2.2. Here root 10 to the power of minus 2. Here 10 to the power of minus 2. 4 into 10 power 4. Finally, that is 10 by 22 here into 2 into 10 to the power of 4. Come outside from the root 10 square. We can write here. And 3 zeros, no? And 2 11s here. 2 11s. And here 1000 by 1 0. And here 2 zeros. 1000 by 11. This is fundamental frequency and is equal to 1000 by 11. So here N1, that is equals to 1000 by, here what is the length is given? 6. And N2 is given, that is 1000 by, so what is the length is given? Here 3. Here N3 is equal to 1000 by 2. The ratio of lengths are written here 6, 3 and 2 here. We know N is inversely proportional to L. N is equals to K by L. K by L. Now, here is what is the common frequency, minimum common frequency. Here, minimum. Here, minimum common frequency. Minimum common frequency is 1000 Hz. Minimum common frequency is 1000 Hz. Minimum common frequency is how much here? 1000 Hz. So the next question is here, a sonometer wire of length 1.5 meters is made of steel. The tension in it produces an elastic strain of 1%. What is the fundamental frequency of steel if density and elasticity of steel are 7.7 into 10 power 3 kilograms per meter cube and 2.2 into 10 power 11 Newton per meter square respectively? So first of all, what are the given quantities in the question? We can write now. A sonometer wire of length of 1.5 meters. L is equals to, here is 1.5 meters. Its length. Is made of steel. The tension it produces an elastic strain. Elastic strain is given, that is 1%. So that means that is delta L by L is equals to 1% means 1 by 100, that is equals to 0.01. Okay, what is the fundamental frequency of steel if density and elasticity? Density is given, that is rho is equal to 7.7 into 10 to the power of 3 kilograms per meter cube. And here is given, that is Y value 2.2. Young's modulus Y equal to, here is 2.2 into 10 power 11 Newton per meter square. Young's modulus of Y. Okay, now here is we know that that is according to Young's modulus formula, Y is equals to FL by A delta L. Here is F is nothing but tension force, that is Y is equals to TL by A delta L. But we know that the fundamental frequency, that is n is equals to 1 by 2L under root of T by mu here. But since here mu is equals to rho A, we know n is equals to 1 by 2L under root T by rho A. So we need to calculate T here, since T is equals to, here capital T is equals to T equal to Y A delta L by L. Here T equal to A delta L. Y A delta L is divided by L. So this we can substitute here at the place of T. Then the fundamental frequency n is equals to 1 by 2L into root Y A delta L is divided by delta L by L, rho A L. Now here A get cancelled. So finally that is 1 by 2L root Y by rho into Y delta L by rho L. Now I am substituting here 2 into, what is L value? So L is 1.5 meters. 1.5 into, what is Young's modulus value? 2.2. 2.2 into 10 power 11 is divided by rho value 7.7. 7.7 into 10 power 3. 10 power 3. Okay, into delta L by L. Delta L by L value is 0.01. That means that is 10 power minus 2. 0.01. Here is, we can write it 10 power minus 2, or here 10 power minus 2 we should write. Now here is, that is equals to 1 by 15 to the, here is 3, and here is point get cancel, 11 to the 11 sevens. 11 to the 22, 11 sevens 77. So 2 by 7 into, here is 10 power 11 is there. 10 power 11, 11 into 10 power minus 5. Finally that is equals to 1 by 3 and the root 2 by 7 into 10 to the power of, okay, 6. Here is like this, and 1 by 3 root 2 by 7 into 10 cube. 10 cube is there. So this is the answer, that is fundamental frequency. If you want to calculate total, okay, you can calculate it, no problem. The fundamental frequency is 1 by 3 root 2 by 7 into 10 cube. 10 cube hertz.